Okay, question 4 is about a sequence that has this formula, un plus 1 equals 4, 2 minus un, and u1 equals 1. Show that it's periodic. So to show that it's periodic, we want to show that it's repeating, that it's going round in circles. So we substitute in the value of u1 to give us the value of u2, which is 4. Then we substitute that in to give us the value of u3, which is minus 2. And then we substitute that in to give us the value of u4, which is back to 1. So our sequence now we can see is going to go 1, 4, minus 2, 1, and then it will keep repeating. Okay, so and that will go on forever. Just keep repeating itself. Now the period is the number of separate values that you have in the sequence. So the period is equal to 3 in this case, because there are 3 separate numbers that it's going to cycle between. It's how many numbers you have in the sequence that it cycles between. It then asks us to find the sum of the first 50 terms. Okay, so we need to work out how many of each there are going to be. Well, firstly, we want to work out how many blocks there are going to be. So if we think about 50 divided by 3, that would be 16, and then there would be 2 left over. So there's 16 full blocks of 3, and then there'd be 2 terms in the sequence after it. So each block would be equal to 1 plus 4 minus 2, which is 3. Okay? So every block of 3 terms in a row, so that 3, that 3, that 3 represents 3, because when you add 1 plus 4 and then subtract 2, you get back to 3. So what we can split it up in is the sum of the first 48 terms, which is going to be 16, because there are 16 blocks of 3, and each block of 3 numbers is worth 3. So the first 48 terms, 16 lots of that, 16 lots of 3 is 48. Then we need to work out what u49 and u50 would be, and we need to add them up. So after we've done a full block, the last one we're on is minus 2. So u48 is going to be minus 2, which then means that u49 would be 1 and u50 would be 2. So the sum of the first 50 is the 48 added to the 1 added to the 2, which gives us, added to the 1 added to the 4. So that's 4 up there, isn't it? I don't know where I got 2 from, which gives us 53 as our final answer. So you're using, it's logic that you've got to use there to work out how many full blocks, then work out what each block adds up to, and then work out any that you've got left over and what those terms would be in the sequence. So that's the 2 remainders, is the 49th and the 50th term, and add them up. Question 5. So question 5, we're going to need to know some formulas for calculating the geometric shapes. We'll start off with drawing the diagram as best as we can. So let's start off with the sector. My sector. And then we've got straight lines here and here. Quite hard to see, but they're straight lines at the end. And we can label a different colour for this. I better label all my points. A, F, E, D, B, C. Okay, and then I want to try and fill in whatever I can. So AF equals FE. So we've got 10.7 there and a 10.7 there. BF equals FD. So these are both 9.2. And angle BFD, so that's in here, is equal to 1.82 radians. Okay. The perimeter of the stage in meters to 1 decimal place. So if we're going to get the perimeter, right, we've got the two 10.7s. We need AB, BD, and DE. So let's start by stating what BD is. So BD is a sector, so the arc length is given by r theta. So r being the radius, which in this case would be 9.2, and theta being the angle, which is 1.82. So that's going to give us 16.744 meters. Now, in order to get A, B, and D, E, we've got to understand, firstly, it's symmetrical, right? You can see 10.7, 9.2, 9.2, 10.6. There's a line of symmetry down the middle of this shape. So we know that A, B, and D, E are going to be equal to each other. Now, in order to get that, we could use the cosine rule if only we had this angle here. Right? Now, again, because it's symmetrical, it's not very symmetrical in my drawing, but it should be symmetrical, you can see that that angle and that angle will be the same. So if we call that x, what we should find is that we can find the value of x by using the fact that this is on a straight line. Now, in a straight line, it would normally be 180 degrees, but we're in radians. So this angle, and this angle would have to add up to 180 degrees, which is pi radians. So we would have the 2x, because we've got x, and we'd also have x on the other side. I'll label it like that. Plus 1.82 would equal pi radians. So then we can get the value of x by rearranging what pi minus 1.82 divided by 2. And that will give us it's 0.66 with some more values. We can then get AB using the cosine rule. So if we're looking at this, the cosine rule for this length here, AB, would be that AB squared equals 9.2 squared plus 10.7 squared minus 2 times 9.2 times 10.7 times cos, make sure you calculate it in radians here, 0.66, but using the full accuracy of the answer that we got from there. Right, that's the cosine rule. If anyone's not sure about that, I'll just write it out here. It's a squared equals b squared plus c squared minus 2bc cos a. You need to have that memorized, right? That should be something that you know and you can recall from memory. So this then gives you, when the AB will be equal to AB will be equal, I'm just working out, 9.2 squared, 10.7. Okay, so we should get 6.6 meters to 1 decimal place for AB. So then we can see if that's 6.6, that will be 6.6 there, and we've already said that this is 16.744. So the perimeter is then got by adding up all of those together, 10.7, 10.7, 6.6, 6.6, and 16.744, which is going to give us, I think I might have skimped on the accuracy a little bit because I'd used 0.66, but I should have been more accurate. it should give you 51.4 meters. So these 6.6 meters might have a bit more of a decimal place when you do it, right? But it should add to 51.4 meters. I shouldn't round there too early, right? Because then that's going to throw off my accuracy here, and we could be more accurate here if we had a more accurate angle here to more decimal places. Okay, so that's question 5A. For 5B, we want the area. So the total area should be quite straightforward from where we are now. So we have three shapes. I think I can show you here. 1, 2, and 3. Now shape 1 and shape 2, right, should be equal to one another. So shape 1 and shape 3. So shape 1/3, we can get the area of those by using the formula for an area of a triangle, which is a half AB sine C. So this is 1/2 times 10.7 times 9.2 times sine x, which is of course that 0.66 angle that we found earlier, right? I'll use the full accuracy this time. Okay, so that should be 30.20856. And then area 2 will be, if we look back at the diagram, so area 2 is the sector of a circle, which again you need to know the formula for, which is 1/2 r² theta, because we're working in radians, so 1/2 times 9.2 squared times 1.82, which gives you 77.0224. So then the total is 77.0224 plus 30.20856 plus another one of that, because there were two triangles, weren't there? Triangle 1 and triangle 3 at each side. So we can add them together and then to one decimal place, which is how they asked me to give the answer. It's 137.4 meters squared. You should have got. Okay, that's question 5, and then question 6. Moving on to that. Okay, some coordinate geometry. So in question 6, we have a diagram. We have a line with equation y equals 2x minus 1 and L2, which is perpendicular to L1 and goes through point A. So we firstly need to find the gradient of L1. The gradient of L1 is given to us as 2. Right? Y equals 2x minus 1 is L1. So actually, we can read the gradient straight off. We should know that the gradient is whatever's multiplying the x when it's in the form y equals mx plus c, so it's equal to 2. Now, because it's perpendicular, the gradient of L2 will be the negative reciprocal of this. So 1 over 2, and we put a minus in front, so it's minus 1/2. That's because perpendicular lines, right, have a gradient that's the negative reciprocal of the other line that they're perpendicular with. So then we can use a formula, whichever way round you like to do it. I like to use y minus y1 equals mx minus x1. You might use y equals mx plus c. And the y1 and the x1 are the coordinates of A, which are minus 2 and I've gone the wrong way around though. The y coordinate is 3 and the x1 is minus 2. So this is y equals minus 1/2 x minus 1 plus 3, y equals minus 1/2 x plus 2. Final answer. Okay, and it asks us, if we look at the form, it asks us to leave it in the form y equals mx plus c, so we need to leave it in that form. Part B, then gives us information about B and C. It says points B and C lie on L1 such that ABC is an isosceles triangle with AB equals AC equals 2 root 3. Show that the x-coordinates of points B and C satisfy that quadratic. Okay, so let's think of our line, our points B and C, as having the coordinates x and y. That's what we're looking to find. Now we know two things. We know that they lie on L1. So if our coordinates lie on L1, right, that tells us that they satisfy y equals 2x minus 1. That's the equation of L1. The point is on there, so they must have the relationship that y equals 2x minus 1, whatever the value of x and y are. The second is that distance. So it talks about isosceles triangle, but really what it's telling you is that the distance AB and AC equals 2 root 13. So we can use for that the distance formula. 2 root 13 equals the square root, and then we subtract the x coordinates and subtract the y coordinates. So A, not written that down yet, A was from the first part, minus 2, 3. So if we substitute in, maybe I'll write this out for you, x2 minus x1 squared plus y2 minus y1 squared. Okay, so it's between B and C and A. So B slash C, that coordinate that we're trying to find, is x and y. So we'll put x and y in for x2, y2, and the A coordinate is minus 2, 3, which we'll put in for x1, y1. So this becomes x minus minus 2 squared plus y minus 3 squared. So you've now got two equations, right? You've got this one, y equals 2x minus 1, and this equation that they both satisfy. So actually, you can substitute 2x minus 1 in for y in this equation, because we know that's the relationship between x and y. So this then becomes x plus 2 squared plus 2x minus 1 minus 3 all squared. 2 root 13 equals square root x plus 2 squared plus 2x minus 4 all squared. Okay, so now we've got an equation. Apparently it's supposed to give us 5x squared minus 12x minus 32. So let's set about cancelling this. So we'll square both sides to cancel the square root. So the left-hand side will have 2 squared times 13, because you square both bits individually. And on the right-hand side, that then leaves us with x plus 2 squared plus 2x minus 4 squared. Okay, so then 52, 4 times 13. And on this side, I'm going to multiply everything out. Minus 16x plus 16. 0 equals 5x squared minus 12x minus 32 equals, and we've already got the equals 0, which is exactly what we wanted. So we've had to use those two pieces of information. Lying on L1 means that y equals 2x minus 1, and that distance, we're using the distance equation and then substituting in and manipulating it. That's part B. Finally, part C. Given that B lies in the third quadrant, this is the labeling of the quadrants, right? So what we find here is the third quadrant. So this is like, it starts here. This is always labeling the quadrant. First quadrant, top right, where they're both positive, and then we go around anti-clockwise. Now 3 will have a negative x coordinate and a negative y coordinate. So that's what we're looking for in our solution to find point B. Now clearly from here, right, you're going to have two solutions because it's a quadratic. You can factorize this, or you could use the quadratic formula and your calculator to help you, right? And we get x equals minus 8 over 5 and x equals 4. Now, one of those is B and one of those is C. The question's already told us there's 2 points, right? Point B and point C. Point B is the one we're looking for, and it has to have a negative x coordinate and a negative y coordinate because it's in the third quadrant, bottom left. Therefore, this one is C, and this one is B, because B is the one with a negative x coordinate. So then, we also know that it's on the line y equals 2x minus 1. So y equals 2 times minus 8 over 5 minus 1, which is equal to minus 21 over 5. That tells me that B is the coordinate minus 8 over 5 minus 21 over 5. And that's question 6.